Hello and welcome to a design example of an AI agent completing structural steel designs. The first question is obvious: can AI agents already do structural steel design? The answer is now yes. This skill was recently unlocked by two recent advances: the sheer intelligence of the latest frontier models and RAGs. Retrieval Augmented Generation (RAG) breaks a steel specification into hundreds of small chunks that an AI agent can query. Steel specifications were chunked, and a RAG database was created that humans and AI agents can query. Semantic search delivers chunks of the specification relevant to the design problem. The AI agent can then follow the spec precisely. On the right side is an example of Opus 4.7 designing a beam column, using Claude desktop app connected the steel RAG. It is sped up but shows the entire design process by Claude without any human assistance. It queries the RAG for the sections itself. The RAG is required since the steel spec is 800 pages and about 1 million tokens. Claude's context cannot handle 1 million tokens. Using the RAG, the specification context is typically 10,000 to 20,000 tokens. Saving tokens equals saving money. In the present example, sections are required from chapters B2, B4, C3, E1, E3, F1, F2, F6, H1 and Appendix 8 of the steel specification. The RAG allows the AI agent to flip around the spec like we do, while only pushing a total of 21,000 tokens into context. Claude collects the sections it needs from the spec, does the calculations, and prepares the report. Example H4 from the AISC design examples is shown, and the Claude design results compare well with the AISC solution. Other examples are being added to my YouTube. This example is a beam column, which is why so many spec chapters were required. The report is prepared as a professional structural engineering document, as was requested in the original prompt. The final design size is recommended, with one design alternative with more reserve capacity. The report follows a standard outline. Geometry, material properties, loads, LRFD combinations. Then the section is designed. The section properties, slenderness values, and buckling stresses are calculated. The report clearly references the sections, tables, and equations used from the steel specification, allowing for easy verification. The compression capacity and then the flexural capacity are calculated. Lateral torsional buckling and elastic and plastic bending are considered. Finally, second-order effects and combined forces checked. Claude noted the section only just passed, so offered an alternate design. This was a nice touch by Claude, as this had not been specifically requested in the original prompt. So how can I get these steel RAG databases and have my AI agent design steel structures, you ask? Well, it's free at my website steelcoldform.com. Take a look at my RAG database page. There's a lot of info on what RAG is, how RAG bridges domain knowledge and reduces AI errors, and gives your AI agents access to the steel specifications. With minimal context use, the AI agent collects the specific calculation approach to comply with the specification from RAG. This allows you to spend tokens on what's most important: Claude correctly calculating the design capacities. From this page you can download RAG databases of hot-rolled steel structures, cold-formed steel structures, and stainless steel structures. For steel there is the main specification 360, the seismic specs 341, 342, and 358, and the code for steel buildings and bridges 303. For cold-formed steel there's the main spec S100, the prescriptive framing S230, code and standard for structural framing S202 and 240. Additionally, the thermal transmittance standard S250, the standard for non-structural framing S220, and the seismic standard S400. And finally, the stainless steel specification 370. With RAG, capacity calculations are done strictly in accordance with the specification, with clearly referenced section and equation numbers. This allows easy compliance tracking and design checking by humans or other AI agents. Set up your free structural steel design RAG to use with any AI LLM model. Step 1. Download the free RAG vector databases from steelcoldform.com. Step 2. Follow the instructions on the engineering RAG page to set up the API for running queries. Step 3. Connect your LLM of choice to your RAG API, allowing your AI agent to query your RAG as required. RAGDBs were created from free PDFs of the specification provided by AISC, and ANSI. All RAGDBs are provided free to promote the use of steel.